The last thing that this section covers is graphing cosecant, secant, and cotangent functions. I'm not going to spend a lot of time looking at these three functions. In fact, the only two that I'll really focus on will be cosecant and secant. I'm not going to focus on cotangent at all. If you can graph either cosecant or secant, then you can graph the other one. So I'll show you kind of the idea of how to graph these things using GeoGebra. First thing that I'm going to do is I'm going to graph the cosecant one, so CSC. And in order to graph that, you first need to start by graphing the sine function. So I'm going to let this thing play out. This is what your normal sine function looks like. Remember, for cosecant, that is an invert or a reciprocal function, excuse me. So when I say cosecant, stop it right there for a second. When I talk about cosecant, I'm really saying that cosecant of theta is the same thing as 1 over sine of theta. And the same thing is true with secant of theta. Secant of theta would be 1 over cosine of theta. So if you can graph sine of theta and cosine of theta, then you should be able to come up with secant of theta. One of the important things to understand, though, is that you are going to have to deal with some asymptotes in here. Remember, if I come over here, here's my sine function. If I'm dealing with cosecant of theta, I'm going to let this one graph as well. You can see what this one looks like. It's the pink one going on involved. Cosecant of theta, its asymptotes are going to be located at specific spots. Wherever my sine function crosses the x-axis, I'm going to say that there's an asymptote there. So if I would draw on the asymptote going up and down, you can see how my graph never crosses that. And it's true for wherever my graph crosses the x-axis in terms of its sine function. The reason that there's an asymptote there is in sine, we say that it is 0, a height of 0. So if I go 1 over 0, because that's what cosecant is, it's the reciprocal of it. So if I go 1 over 0, that then gets me undefined. So anytime it crosses the x-axis, you need to draw in an asymptote at those locations. Since cosecant comes from sine, we're going to say that the period is still normally 360 degrees. There is no amplitude, though, because I'm not really dealing with a specific height that's going on involved here. Okay, so I'm going to give you one example, and then we'll go from there. And in fact, we're going to focus on graphing secant of theta. So I want to come up with what is the amplitude, period, and I'm looking for, well, actually, yes, I'm going to do it a couple ways. So I'm going to say let's deal with the graph 2 secant of theta over here, where I want to know what is the amplitude and what is the period. But in order to graph 2 secant of theta, I really need to focus on y equaling 2 cosine of theta at the same time, since secant comes from cosine. Over here, I want to know what is the amplitude of the cosine, the period, and I want to know what is the intercepts as well. So if I deal with cosine, we know that the amplitude is 2, the period is 360 divided by 1, so 360. Our intercepts come from taking a fourth of 360, which is 90, and 3/4 of 360, which is 270. We've done all of this on previous examples. So we're going to graph the part in purple first. My amplitude was a height of, so I'm not going to go up that high. My amplitude was a height of 2, so 2 and -2. I have a period of 360, tack on another 360, that's going to get me 720. My intercepts, those are going to be at 90 and 270. 90 plus 360 gets us 450. And 270 plus 360 gets us 630. We'll graph this. Remember, we're dealing with cosine. Cosine starts up at the top. So I'm up at the top there. I'm up at the top at 360 and 720. I'm crossing at 90 degrees and 270, at 450 and 630. If you want, this spot is 180. We're down at the bottom. And between 450 and 630, 180 plus 360 gets us 540. We're down here at the bottom as well. So cosine there's my cosine function. That will help us graph our secant function. In terms of our secant function, there is no amplitude, so we're calling this undefined. And our period is exactly the same as what our cosine function is. So 360. Remember, we're dealing with asymptotes involved here. The asymptotes are located. I'm going to get rid of this here at the bottom. Our asymptotes are located where it crosses the x-axis. So right at 90 degrees and 270, I'm going to draw in my asymptotes. There's my asymptotes. And then your secant function, find the bumps. Your secant function is the part that I'm drawing in blue right now. Notice how I'm not trying to cross the asymptotes as I do this. So the parts in blue represent the actual graph that we're looking for, but in order to get to that, you have to graph the cosine function. The good news is that secant is pretty much the same thing, except instead of drawing in the cosine function, you draw in the sine function first.